Hello, Calc BC students. This is Ms. Orloff here, and we are going to go through another FRQ from 2009. This is a calculator OK problem, and it essentially is going to cover integrals as an accumulation function. We've done a lot of position velocity and acceleration, particle movement, so we want to show you a different use for integration. So I'd like for you to pause this video. Take the time to pull out your calculator and open up your OneNote. This problem has been sent to your OneNote, and get ready to do some work. So I'm assuming now that you have the problem in front of you and you have your calculator. I want you to go ahead and read this problem. All right. Before I continue on, I want you to know my co-teacher Izzy and Ginger are both here, and Izzy is sleeping currently, and you may hear the snoring in the background. So things you need to pay attention to. I am given a rate. I always want to pay attention to whether I'm given a rate or a total amount or what that given equation is representing. And in this case, it's a rate of people entering into a concert. And this rate is only good for this particular time period. So those are things we want to pay attention to. The rate is measured in people per hour, and we want to see if there's an initial amount of people. And at time equals 0, we do not have anybody in the auditorium when the doors open. And the doors close when the concert begins at t equals 2, which again lends itself to saying no more people will enter the concert at this time. All right. So we want to know how many people are in the auditorium when the concert begins. We are currently working on part A. This is a calculator OK problem, and what we need to realize from the College Board is we cannot have like a bald answer. I cannot just write an answer down. So you're going to need to write, at a minimum, the integral setup. However, when you have your calculator, you should not be attempting to integrate by hand. So what we're going to do is you're going to go ahead, pause the video, and get that function of r of t into your calculator. I'm personally going to put it into y1. Okay, so you see that I've placed the function into y1. I just want to confirm that I've entered everything properly since I will be working, doing all of my mathematics using my calculator. So this is just a simple integral. So if we go back to this problem, we know that our integral setup for part A is as simple as the integral from 0 to 2 of r of t dt. And yeah, the College Board allows us just to write that r of t dt instead of writing out the entire function since it was defined as r of t. So I know that that's in y1. I'm going to go ahead, in case you've forgotten how to use your calculator to integrate. We hit Math 9. I'm going to run that integral from 0 to 2. And one way, if you have the new operating system, to quickly pull up y1 is alpha trace, enter for y1, dx. If you're struggling with the use of your calculator, I'm going to encourage you to join in on one of your teacher's live conferences with you to kind of discuss how to manage that. And we see that our answer is 980. So we have exactly 980 people are in the auditorium when the concert begins. Okay, we're now ready to move on to part B. Find the time when the rate at which the people enter the auditorium is at a maximum. This is one of the problems I feel that a lot of students will rush through and they're not paying attention to what's really being asked. You are not asking for the max amount of people, you are asking for the max rate in which people are entering. And then we need to justify our answer. So I always say to my kids, let's just take a moment, take a step back and think about, in calculus, how do we think about finding maximums of anything? And we always look to the derivative of what we're trying to find a max of. So in this case, we're going to want to find r prime of t. And again, we have a calculator. We don't need to find that by hand. So go ahead and open up your calculator to your graphing screen. Okay, so we know we need to find out when r prime of t equals 0. That's going to find our interior critical points. So critical points are defined by when the derivative equals 0 or is undefined, as long as that value is defined for the original function. In this case, we know we have a cubic function and it's defined on its entire domain, so we're only looking for r prime of t equaling 0. The College Board expects you to write that down or show that. Again, no bald answers. This here gives you 1 point on the test. So we are going to go ahead and use our calculator to help us solve that. So at this point in time, I don't care about the graph of r. I care about the graph of r prime. So I'm going to turn off the graph in y1 and go to y2. And I'm going to ask my calculator to graph the derivative of r for all values of t from 0 to 2. I only want to see the values I care about in the window. Okay, to do this, to refresh your memory, we hit Math, 8. I'm going to take the derivative with respect to x. I'm going to pull up y1 by alpha trace again. I need to graph it for all values, so x equals x. Again, I've turned off y1. I don't want to see that graph. I'm going to adjust my window. I only care about the values from 0 to 2. And I have to think about, at 2 hours, if there was 980 people, I want to think about what that rate would look like. How big do I need to make my window? I'm going to encourage you to pause this video and figure out your Y min and your Y max. Okay, you can see I've opened up my Y min and max pretty large. However, it's not necessary if I'm looking for that critical value. I want to know when r prime of t equals 0. So I'm really focused in on that horizontal axis. And I'm looking to see when it equals 0 and if there's a sign change. So I have my graph set for us, and we need to find that point of intersection. The next thing we need to do is we need to store that point of intersection because the College Board expects us to be accurate out to 3 decimal places. So I'm going to go ahead and find that point of intersection. I said point of intersection, that is if you graphed y equals 0 in another graph, or we want to find the 0. So go ahead, find the 0 or find the point of intersection. Okay, you can see I found the 0 at x equals 1.362967. My graphing calculator automatically stores that in x. So if I go back to my normal screen and I hit x, I have it. However, if I didn't want to store it in that, I would have gone immediately back to the screen and did a store in any other variable I want. Okay, so on my paper, I'm going to say, well, I know this is when t is approximately 1.36296. So that's our interior point. But we also have to remember we have endpoints when t is equal to 0 or t is equal to 2. The College Board is going to require something called a candidates chart, and how you choose to organize that is up to you. But we need to find when r of 0. So we figured out the critical points using the derivative. Now we need to find the actual rate at the endpoints and the critical values. So r of 0 we need to find. We need to find r of that 1.36296. And we need to find r of 2. I have two ways I can do this. I could look at a table of values, or I can quickly do things right here in the screen by doing alpha trace y1, and I'm going to find that it's 0, which we already should know it's 0, right? I can go ahead and do alpha trace of y1, and I'm going to use that stored x value. And then I'm going to do alpha trace y1 at 2. I need to write these three things down on my paper, so please pause and make sure you write that down. Okay, take a moment and read my justification for part B. So I'd like you to pause the video, read through that, make sure you understand it, and then take time, read through part C, and see if you can set up that problem on your own. So pause the video now. Okay, before I work through part C, I want to quickly denote the points that would have been given. In part A, 1 for the integral, 1 for the answer. In part B, 1 for showing the that r prime of t needs to equal 0, 1 for finding that interior critical point, and 1 for my justification. Part C, now when I copied this, it copied really small, but I wanted to have that in front of us as we were working. So I'm going to go ahead and get that at a right level for us. So you should have read through. So now we have a new function that has been introduced into the problem, and it is W of t, which is total wait time for all people who entered the auditorium before time t. And they've given us the derivative of WT. Okay, so that rate of change of wait time. It's going to also incorporate R of t. We can't forget that we've placed that in Y1. And they want you to find the W of 2 minus W of 1, the total wait time for those who enter the auditorium after time t equals 1. So go ahead and write an integral setup for this problem. So going back to our handy dandy fundamental theorem of calculus, we should understand that this integral gives me W of 2 minus W of 1. Showing that integral setup would give me 1 point for this problem. However, in our calculator now, we are going to need to enter this. So we are now on the screen. We are going to hit Math 9 from 1 to 2. And we are going to go ahead and put in 2 minus x. Again, Izzy is definitely snoring in the background at this point in time. Y sub 1, because we know that we have R of t and y sub 1, dx. All right, let's write that on our paper. Okay, you can see my write-up there, and that answer gives me another point. We have one more part to do in this problem, and that is part D. Pause this video, take a moment to read that problem, and think about your setup. All right, so here's part D. One of the biggest cues on how to handle this problem is right here, on average. We want an average amount. And sometimes I really feel strongly students need to take a step back and think about when I want an average. And in this time, I want an average on how long a person waits in line. Wait in the auditorium for the concert to begin. So what I need is total wait time. And then I need how many people are in the auditorium. Okay. The things I wrote in orange isn't necessary to write down in the way that I've written them down, but these are things we need to consider. The total number of people at t equals 2 hours, and then we needed to tweak our integral from part C a little bit. We needed to start it from 0 to 2, so we need the total wait time after the doors of the auditorium had opened. So this is the integral I would need. I would need 1 over 980 times the integral from 0 to 2 of 2 minus t r of t, that is from part C, dt. And this should all make sense after you look through what I wrote in orange. And here is my final answer. Hope everybody has a good day and please stay safe.